generators and motors, identifies single and three-phase motors, capacitor start, squirrel cage induction motors, connection of single-phase, three-phase motors to supply main, reverse directional, okay, in the reverse direction of motor rotation, discuss the factors affecting reversal of rotation, main auxiliary winding, capacitor and phase displacement, explain the difference between synchronous speed, rotor speed, disk slip, pole frequency. Well, all of these seem to be um, very technical terms, but as you see from past paper questions, we are pretty much asked to label the parts of the alternator and in some cases the dynamo, and then explain the function of the main part. So we're just going to do a quick overview. Um, okay, so a generator. What is a generator? A generator is a device that uses electromagnetic induction to convert mechanical energy into electrical energy. So let's look at what that says. It uses electromagnetic induction to provide electrical energy. All right?
What is electromagnetic induction?
All right. Now, electromagnetic induction is when you move a coil of wire between the poles of a permanent magnet. A voltage is induced into that conductor, and that voltage is called EMF, or electromotive force. So simply put, if you just move a conductor, I don't know what to do. What should I recommend? When you join it order. When you join with Alright, so basically it's saying, and I'll have to show it to you on in subsequent slides. So basically when you move a conductor between magnetic poles, the north and the south pole, you know that the force of attraction will be taking place between the north and the south pole. Therefore, the lines of force will move across. They'll be invisible to the human eye, but they will be operating between each other. So once you move a conductor between them, a force will be induced into it. An electric motor is a device that converts electrical energy into rotating mechanical energy. And can anyone tell me an example of a practical device that uses an electric motor? Anything around your house that uses an electric motor?
A fan.
Yes, a fan. What else?
Yeah, you see.
What about inside the kitchen?
Your fridge, your microwave.
What about your blender?
You know, blender.
Anything that has a moving part uses a motor. So the motor is like the opposite of the generator. So the motor uses electricity to provide mechanical energy, while the generator uses mechanical energy to provide electrical energy. So both motors and generators are used to supply electricity to consumers. AC generators produce alternating current. AC motors supply power to loads. So generators produce alternating current while motors supply power to loads. All right, and that power is in the form of mechanical energy. The AC generator is called the alternator. Okay. All right. So now this is a simplified look at an AC generator, and I'm just going to use the simplified look to show you how magnetic induction takes place. All right. So you have a north pole and a south pole. We know that north and south poles are the ends of the magnet, and the poles are where the strongest concentration of the lines of force in a magnet will exist. So the poles have this invisible line of force called flux. And laws of magnetism state that opposite poles will attract. Therefore, the north pole will be attracted to the south pole, and the lines of force will spread across. Now, as the lines of force are going from the north pole to the south pole, a conductor that is placed there um, attached to the shaft. So this is the shaft. The shaft is a metal rod that is used to rotate the armature. The armature or wire loop is basically a coil of wire that is wrapped around the shaft. Now this coil of wire wrapped around the shaft is attached by slip rings, which now, as you can see, one end of the coil loop is attached to one slip ring, the other end of the loop is attached to another slip ring. I don't know what to say, Alan. Tap the screen and look for the mic. All right. Right, so as you can see, one end of this coil is attached to one slip ring, the other end is attached to the next slip ring right there. Okay? So the slip ring makes the electrical connection between the conductor. So what's happening now is as the shaft rotates through the field, the magnetic field, a voltage is induced into this shaft, right? Sorry, into this armature coil. A voltage is induced into this armature coil. Now that voltage now is moved into these brushes that you have here. You have these brush circuits right here. And these brush circuits are not physically touching the slip ring, but the brushes now will collect the electrical energy being generated from the armature wire. Now, has any of you ever seen or experienced um, sparking? Like if you pull a wire, if you pull the cord out of a socket too quickly,
Yeah.
so you see sparking taking place. Most of you ever seen that?
Yeah.
Right. Now inside this generator, sparking is the method by which the electric current now moves from the Tell me you have two accounting. All right.
Yeah, I'm having technical difficulties.
Okay, cool. All right. So this the sparking is where the electricity now the electrical energy now moves from the slip rings into the brushes. And that can be witnessed by the sparking or arcing. Arcing is basically when electrons are pulled into open air. So basically, when electrons are pulled into open air, it looks like lightning striking or what we call sparking. So that's the purpose of the brushes. Now, this is a basic look at the generator. Let me go over again. The purpose of the shaft is this metal rod that is used to rotate the armature or wire loop. So basically, if you put one conductor through a strong magnetic field, voltage will be induced in that one conductor. But if you take that conductor and create a coil where that conductor now has many turns, it will now multiply the rate at which the voltage is induced into the coil. So therefore, what happens now is that this armature coil is being spun or rotated between the fields of this magnetic lines of force, and voltage is being induced in the coil. The voltage induced in the coil is transferred into these slip rings, which are connected electrically by a small space, a small air gap between the slip rings and the brushes. And so the brushes now will collect the electricity generated in these armature coils and pass them into the brush circuits or the load. Now, there are certain factors that affect the amount of electrical energy produced in a generator. The number one factor is the number of poles. If you increase the number of magnetic poles, you increase the rate of electrical induction per turn. As we will look in further diagrams, you will notice that electromagnetic induction does not take place at every rotation. It takes place at 90%, 90-degree intervals, which means the conductor and the magnetic field must always be at right angles for induction to take place. Another thing that affects the rate of induction is the number of turns on the armature coil. The more turns, the stronger or the more electricity will be produced. Also, the type of material that is used the type of material that is used to make the armature loop that affects it as well. Then, of course, the speed at which the conductor